Hello, hello. Welcome to the past Business Analytics Marathon. We are excited you could join us today for James Kobielus' session, Unlocking Big Data, the Power of Cognitive Computing. My name is Paco Gonzalez. I'm the leader of the past Big Data Virtual chapter, and I have a few quick introduction slides before I hand over to James. Hello, James. James, please move to the next slide. Great. If you're having any issues, type your issue into the question pane and someone will assist you. To maximize your screen, use the Zoom button located on the top of the presentation window. Feel free to enter your questions in the QA field at any time. The questions pane is located on the right side of your screen. Once we get to the QA portion of the session, I'll read off your questions to the speaker. Note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will show up on your screen. James, please move to the next slide. I will also take a moment to thank our event partners. The staging of the past Business Analytics Marathon will not be possible without their support and dedication, and they are the reason this event is available to you free of charge. Thank you to our presenting sponsors, Microsoft and Hortonworks. Let's go to the next slide. James D Covillas is an industry veteran. He serves as IBM's Big Data Evangelist, as Senior Program Director for Product Marketing and Big Data Analytics, and as Editor-in-Chief of IBM Data Magazine. Kobielus spearheads IBM's thought leadership activities in Big Data, Hadoop, Cognitive Computing, Enterprise Data Warehouse, and Advanced Analytics. He advised IBM's product management and marketing teams in all things around big data. He has spoken at leading industry events and has published several books. At the past Business Analytics Conference this year, James will be presenting a 60-minute session on unlocking big data, the power of cognitive computing. So let's move to the next slide. If you want to connect with James, or if you have any questions after watching this webinar, you can contact him via these mediums. So let's go to the next slide. The past Business Analytics Conference is on April 20 to 22nd this year in Santa Clara. The conference is designed to follow the analytics journey from sessions covering the discovery and iteration of data to analyzing and interpreting data and communicating insights throughout your business. Along the journey, you'll gain the critical business and data analytic skills you need today to stay ahead of the curve. Industry experts and professionals will show you how to use technology to uncover insights and deliver new value to your organization. The unique design of the conference gives you practical and indispensable knowledge you can use immediately. So let's go to the next slide. And without further ado, here is James with his presentation, Unlocking Big Data, the Power of Cognitive Computing. So go ahead, James.
Thank you, Paco, and hello, everybody. It's a pleasure to be speaking to you today. I'm Jim Kobielus. As Paco indicated, I'm with IBM. I do thought leadership, evangelization of the power of big data in business, in the consumer world, in life in general. And one of the hot frontier themes in big data is the notion of cognitive computing. In some ways, in many ways, this is artificial intelligence for the 21st century of big data, unstructured data, data in Hadoop, data in NoSQL databases, and so forth. So what I'll present for the next 20 to 25 minutes is a foretaste of what I'll be discussing at the BAC PASS conference in April in Santa Clara. Think. You know, cognition is all about, it is thinking. Cognition is thought processes. And if you're familiar with the history of my employer, you know, it's think has been our motto from the early days of Thomas J. Watson Sr., Thomas J. Watson Jr., and you know, so in many ways the word think is, you know, as a general, I guess you can call it a mantra for IT. It's not just an IBM thing, it's thinking machines. That's what computers have been since the start. That's the very nature of computing. And there's various types of thinking, thought processes that can be automated to greater and lesser degrees using automated information systems. Thinking, how can we do it better? Not just thinking in our minds, but thinking with computers. How can we make computers more efficient, faster, more agile and flexible in terms of handling the automated information processing that is associated with thinking-like processes, cognition-like processes, cognitive computing. How can we do it better? How can we not only make machines think better, but how can we make the humans who use machines, help them to accelerate their own thought processes so that we all can think better, more creatively, more flexibly under a broader range of circumstances, including especially when we're out in the big, beautiful world with our smartphones and we're looking for automated guidance from the cloud about what we should buy and where we should drive our car. Should we turn left? Should we turn right? Should we stop into that store? Should we avoid particular situations because they may be hazardous to us, or that what should we do? How can we do it better? How can we think better? Thinking, also known as cognition, is the fundamental thing that business intelligence, business analytics, decision support applications are here to help us with. Thinking, cognitive processing, really to help human beings to make better decisions, to discover all the data that is out there, to learn from fresh data, and to drive a broad range of decision processes applications, really to improve cognitive processing on all fronts. And when we think about cognitive processing that humans do in our minds, it's good to break it out into 4 broad areas of cognitive processes that can be facilitated and improved through business intelligence, business analytics, cognitive computing. First of all, one important set of cognitive processes is getting a sense for what's happening now and what's been happening in the past in terms of data on how your business has fared, whether your customers are happy, or whether your company is on the right trend in terms of boosting profitability, cash flow, and all of that. So discovery of data and exploration of that data to figure out what has been happening and what is happening now, critically important. That relates to things like stream processing, stream computing, and so forth. Why did it happen? It's not enough just to have all the data, all the historical data available to you, as well as all the current streaming data. What you want to know is why did it happen, or why is it happening? So you use the heart of business intelligence, which is reporting tools, analysis tools, dashboarding, scorecards, content analytics, to try to get a sense for root cause analysis, or also trend analysis, the underlying, why did it happen? And just as important in plotting out your strategy going forward in almost anything you do, figure out what could happen, what is likely to happen under various realistic scenarios based on what's gone before and what's, what the statistical probabilities show is likely to happen under various circumstances. Are customers likely to stay with us? Are they likely to accept this next offer? So on and so forth. There's a broad range of predictive analytics and modeling capabilities that can help you to establish a great degree of confidence in your forecasts and in your predictions. You need data. You need statistical processing. Cognitive processing in general to be facilitated for you within your tools, within your database environments. And not just what could happen, what action should I take? Decision management tools, automated guidance, recommendation engines. Next best action is a variety of terms used to describe the applications to help you frame up what is the best alternative option for you under various likely circumstances based on what has happened and is happening. So that's really, these are cognitive processes. These are things that you need support on in making decisions to how to run your business or how to live your life. And these are not just things that you do in your mind, but these are the heart and soul of what analytics and decision support, business intelligence help everybody to do now in the modern world. More and more of it's becoming cognitive processing in a self-service cloud agile environment. So thinking better, like I said, is really what computing's been about from the very start, helping us to accelerate our ability to think and to absorb data and to look for patterns and correlations in data and to make better decisions under a broader range of scenarios. If you look at the historical long view, and I'm with a company that's been in existence for more than a century, so I myself haven't been here this long, but nonetheless, when you look at the historical long view, it's clear that when we talk now about cognitive computing and cognitive systems, there's a long lineage, and this is really a new phase now, a new era in computing. And why is it new? And I'll explain. It's not just marketing. It's not hype. It's real. I'll explain what cognitive systems are and why they're so radically different from what's come before. But they build on and improve the computing infrastructures that we all use. Really, if we start from the broader definition of cognitive computing, then we can work our way back and understand how we've evolved and why we are evolving in this direction. Really, cognitive computing is all about deriving unparalleled insights algorithmically from fresh streams of big data. So the insights are derived through algorithms that are implemented in libraries, on your big data platform. They're machine learning and deep learning and artificial neural networks and so forth. And that really, in many ways, if you look at machine learning, it's the very heart and soul of cognitive computing. It's really to help us see patterns in the data that we mortal human beings couldn't see unassisted. We need the algorithms to be automated, accelerated in cloud computing environments to help us sift through petabytes and exabytes and beyond of data in real time to figure out what's going on. So when you look at the long haul now of evolution of computing architectures, starting back from around the era of the early 1900s, there was the tabulating systems era. And fundamentally, that's where computing began in the 19th century with Herman Hollerith and Charles Babbage, and also with IBM. We were originally the computing tabulating recording company. That was the original name, and that sort of indicates where we came from, where everybody came from, which was mechanical and electromechanical calculators and adding machines and tabulating equipment. That was the state of the art of what we came to call computing. And in fact, they called it computing to varying degrees back then as well. But it was all about the actual logic, the execution logic for what we now call cognitive processing was handled in hardware, and it was a hardware engineering feat, and it was a brilliant feat. But the advances that were made early on, and really up through the start of the next systems era, really around World War II and beyond. Programmable systems era, it was all about hardware innovations. Even in World War II, Alan Turing and the folks in Bletchley Park in England who built the machine that was able to decode the German Enigma code, that was largely, not completely, but it was largely a hardware engineering feat, and what they built was brilliant. And they brought, of course, more of an electronic digital architecture into computing, and that really set the stage for the coming era that we're still obviously very much in, which is the programmable systems era, where the actual computing logic, the cognitive computing logic as it were, was not just baked into or burnt into hardware and firmware and so forth, but was software programmable. That this is the era of programming, so COBOL and Fortran and C and C++ and Java and every other modern language. It's all about programmable systems, and computer programmers, the whole discipline and career sprung up as the heart and soul of how you define the intelligence that powers the modern era. Now, turn it to a new century, a new millennium, and we start to see a new era unfold. We are in the era, of course, of big data. Far more data than ever before is being used across our lives, not just in business, but in our own consumer world. We all have far more data than ever before, and also we have a far greater reliance now on statistical and predictive analysis, machine learning models, and so forth, to extract patterns, to find correlations, anomalies, and outliers, and so forth in the data. And then far more applications are built on embedding of statistical logic, such as recommendation engines, for example, that help people to sort through what's best for them. And all of these machine learning and statistical algorithms are baked into the very fabric of cloud applications now. And really, this is the cognitive systems era, because more of the actual execution logic for modern applications, especially cloud applications, is derived increasingly from the data itself, from the patterns, the segmentations, and so forth, the predictive variables that are seen or sensed, as it were, by automated systems that incorporate machine learning and deep learning for pattern recognition, face recognition, and so forth. So the cognitive systems era is all about deriving the more and more of the processing logic directly from the data. So as you can see, it builds, because cognitive systems built on big data and machine learning have not caused programmable systems to be obsoleted. Far from it. Clearly, it's an overlay of big data and statistical logic on top of programmable systems, and of course, the hardware embedded processing logic, firmware, and so forth is the foundation of all computing. So it's a matter of evolutionary building of a new layer, of a deeper layer of processing logic. So fundamentally, hardware processing logic starting about 1900 and really still underway, software explicit processing logic starting after World War II, and data-derived processing logic as really defining this new era of cognitive systems. So it's all about the cognitive revolution. Dynamically optimized application logic without hardwired or explicit programming. That's really what it comes down to. The processing logic increasingly is derived implicitly from fresh data being processed by machine learning models and so forth in the cloud. So cognitive computing, to back up, here's a sort of a canonical definition that can help you to get your heads around what exactly is this. It's the ability of automated systems to handle the conscious, critical, logical, attentive, reasoning, and evaluative modes of thought. In other words, to handle more really artificial intelligence. But really, artificial intelligence that's inline to actual applications, not artificial intelligence that's purely in the laboratory, an R&D, curiosity or whatever. It's really inline production artificial intelligence in big data. It's all about automated systems' ability to learn from not only from the data, but also from the data that comes from interactions with people. People's interactions with applications such as IBM Watson, that are powered by big data and machine learning, but also very much are fed fresh intelligence from the ongoing interaction of human users with the data, with the models, with the applications that build on it all. And just as important, cognitive computing is the ability of these systems to adapt their behavior to these inputs, fresh data as well as fresh interaction data, without explicit programming, so that the automated systems can take the best next action based on all of this information, the best models, the best data, increasingly in real time, such as in stream computing environments, to drive recommendations and guidance and so forth that's in many ways transparent to the end user. It's built into your mobile applications. It's built into all your social applications. Here's people you probably know, those kinds of suggestions from Facebooks and others, for example, are powered by all of this. So now here's the obligatory mention of, yes, once again, IBM. We pioneered and advanced and continue to advance cognitive computing. And if you look at the long lineage of really artificial intelligence, well, you can date it, of course, from Alan Turing and so forth. But also, really, in many ways, cognitive computing, artificial intelligence got a big boost in terms of maturation, starting in the 50s with the growth of business-grade natural language processing, and we were among the pioneers in this area. In fact, I just pulled an article from IBM Journal back in the year before I was born, on something that we had developed back then, a statistical approach for mechanized encoding and searching of literary information. Doesn't that sound like search engines? Well, yes, search engines are very much powered by this technology, but it was like bleeding edge back in the 50s. Now it's mainstream. It's been mainstream for a long time. But we haven't stopped there. Clearly, Watson, which began in IBM research in the labs and began to be developed into a commercial solution about 10 or more years ago, and builds on natural language processing and layers it with statistical analysis, machine learning, big data, multi-structured sources, semantic search, conversation optimization, and so on and so forth. It's an ongoing development of a cognitive computing infrastructure that we refer to as Watson, which is many things, and I won't spend an inordinate amount of time talking about our solutions in this particular session, but just want to point out that it began as a research project. The world at large became aware of Watson, 4 years ago now. In fact, this month, 4 years ago, the Jeopardy Grand Challenge. And Watson did quite well for itself in cleaning up. And what it proved was that automated information systems can hold their own in a variety of decision scenarios and action scenarios that go beyond what we traditionally associate with artificial intelligence. To be, in many ways, a more formidable competitor to human decision makers under some scenarios, such as we obviously built and tuned Watson to that particular quiz show challenge, but we've gone way beyond there. In fact, that process was well underway when we mounted the Jeopardy Grand Challenge. Over the last 4 years, we've progressively productized Watson technology for a variety of vertical markets and horizontal applications, from healthcare to financial to multi-channel consumer engagement and so forth. And we have, of course, established a Watson Solutions division to productize it further, and it's very much at the heart of where we're going. So coming back to the coming out of Watson on Jeopardy, what was new about what we were doing then? Fundamentally what we're doing now, for that matter, which is decision support in a quiz show context. Well, clearly, this wasn't the first time that IBM has built an automated information system and tuned it to rock and roll in a game challenge. Back in the 90s, we built a system and tuned it that beat the chess grandmaster champion of the world at chess, which is clearly a game show, or actually I should say a game show, gaming challenge of very long vintage. And so what we started to prove back with that initiative was that, and clearly we did it in a very high visibility public environment, is to show the power of cognitive computing for very well focused domain challenges. And so you can look at the Jeopardy Grand Challenge in that light. We took Jeopardy, a different game, a game that involves natural language, that involves human interaction, that demands speed. And we were able to show that, wow, artificial intelligence has advanced into a powerful new era of the 21st century. So clearly what we did is we did all the things that I described with cognitive computing. It was natural language processing. Question and answering was something at the very heart of what Watson can do. Watson's core technology is called Deep QA, and it's built for, and I'll discuss it in a moment, a particular type of question answering environment. The ability of Watson to learn from unstructured text in a complex domain space requiring broad general knowledge, linguistic sophistication, something that all of us can do naturally, organically. Anybody who's educated or has a brain in their head, which is all of us, can do reasonably well in these kinds of challenges, but it hasn't been easy for machines to do well in these kinds of challenges. But also, of course, we built Watson to interact naturally with the participants in that gaming environment, Alex Trebek, the other human contestants and so forth. And Watson adapted its behavior throughout the game without explicit programming, able to identify, buzz, and voice correct answers with speed and precision and so forth. So these same enabling technologies, we've applied these more broadly in a variety of industries and solution domains, and I've laid out what we're doing at a broad level in terms of productization. But the Jeopardy challenge, so when you look at it, there's all the answers that you're supposed to phrase questions to, and they come in a broad open domain, a broad range of domains. Each of those categories is a complete semantic domain in its own right. And Watson, just like the contestants, didn't know in advance of the game which of those categories would be selected for that particular game. So you have to be agile conceptually with a broad knowledge base and broad knowledge corpus, and Watson had a very broad general knowledge corpus available to it in advance, and be able to process complex language. Look at this, parsing natural human language. Clearly human language, any human language, not just English, is excessively complex in terms of nuances and things like irony and sarcasm and ellipses and so forth that we take it for granted because we've grown up in a particular language, but you have to build to tell a machine explicitly exactly how to parse a natural language in order to be even reasonably competent at answering even simple questions. Be able to answer with not only to understand and parse the language, but answer these questions with high precision and high confidence within a split-second time, and to be able, as it were, to buzz in with the answer that which it had highest confidence, Watson, before the humans metaphorically side by side with it in that contest could do. And Watson met these challenges with glowing colors. So really, Watson's cognitive fabric learns adaptively on the fly and grows its knowledge corpus and tunes its contextualization of the kinds of responses that are relevant and appropriate within any given context or domain into which it's brought or adapted. So it's all about understanding natural language and human-style communication, Watson, cognitive computing. It generates and evaluates evidence-based hypotheses, what might be the most relevant answers, or in a Jeopardy context, the most relevant questions pertaining to the answers. And then adaptively learns from both the training data, the corpus that it had in advance, but also to learn, as it were, by the seat of its virtual pants to provide high confidence answers from a very broad knowledge domain that human contestants probably can't store the entire Encyclopedia Britannica or whatnot in their minds, with any detail, but Watson can certainly do that. Okay, deep QA, the soul of Watson's cognitive fabric. So it's basically, this is the core of what IBM began to develop in the labs and then rolled out in a commercial way in the past 10 years. It's based on natural language processing. It's cognitive computing at its very core, and really, it's to enable more flexible, broad domain, real-time interaction between the computer and humans, a human-machine interface, leveraging big data, massively parallel processing, probabilistic logic, and so forth, in an evidence-based architecture. And so I'm not going to belabor or go into detail on the actual underlying plumbing of how Watson works. You have these slides, and we can always send you far more information. But the important thing to know is that what it does is that Watson essentially absorbs big data, and then it also parses the questions that are posed to it, and searches through its corpus of big data to rank by relevance to questions that are asked, to rank by the relevance the data that's available, and then generates a list of relevant responses. It's a ranked list by confidence to help individuals to get a really strong sense for the range of potential responses, and then users can, through their actions, by clicking on one thing or another, or one or another result that Watson has presented, Watson will then take that information and factor that ongoing into its response to similar questions from similar users under similar scenarios in the future. So Watson learns from humans' judgment about what's relevant. So fundamentally, Watson, Deep QA, it's all about machine learning and big data. Big data is the foundation. Huge volumes of data, petabytes and beyond. The full range of data from structured to unstructured, social and event data and geospatial and so forth, at high velocity with stream computing, and clearly IBM's big data and information management portfolio is well represented inside the guts of how Watson actually works. So Watson's cognitive fabric uses machine learning to find deep patterns within big data. And machine learning, in a nutshell, is statistical algorithms for learning from data. It abstracts quantitative models from the data and from prior knowledge, and enables data-driven analysis, inference, pattern recognition, and prediction. So the modern world of face recognition and voice recognition and searching for patterns, sentiment patterns, and so forth in social data and all that, it all rides on machine learning. And machine learning, deep learning, there's a lot of terms that are used to refer to various approaches for doing this. That's all at the heart of Watson. So with that, I want to apologize for the technical glitch we had and open it up to any questions you might have. So Paco.
Okay, so if you have any question, you can type it on the QA section of the webinar tool. So let's wait a little bit.
And let me point out that if you can't or don't want to ask me a question today on the call, you can send me an email to my IBM email address, and the organizers will send that to you offline if you're interested.
Great. Thank you very much, James.
Sure.
If you are interested in accessing other free educational content, the PASS organization has a variety of virtual chapters which offer free webinars to their members every month. Check out upcoming webinars and recordings of past webinars from our business analytics, Excel BI, business intelligence, big data, and cloud virtual chapters by visiting sequelpass.org.vc. So I'm going to read one question.
Okay.
Where does this lead us with societal predictive analytics? Will it all be managed for us, good or bad?
Well, will it all be managed for us? I think the one thing that's important to note in this cognitive fabric is that human beings certainly have not become irrelevant from the development standpoint. Yes, we can derive more of the processing logic directly from the data, but who's developing the algorithms, the predictive, the statistical logic? It's a new generation of developers, often known as data scientists. In many ways, the data scientist is the new application developer for this new era of big data and cognitive computing. So, fundamentally, more and more organizations are investing in data science and in the tools and in the people and in their education, the curricula, to not only hire fresh minds out of the universities and so forth, but also, in many ways, people who've been in the development world for a long time are realizing that their career prospects and really the cool new projects increasingly involve a heap and helping of data science to do things like machine learning and deep learning for all these applications, recommendation engines, and so forth. So the important thing is, the models and the data don't manage themselves. The models will be built by this new generation, as it were, a developer, the data scientist. The data and the models will need to be governed. Governance, model governance, data governance are very human activities, and so organizations need to invest in data governance. But that's not anything new. I mean, most enterprises realize that the data doesn't cleanse itself. You need stewards and so forth who have responsibility for ensuring that, say, the financial data in your financial data warehouse is in fact the latest and greatest and correct version. But also, increasingly unstructured data governance will come to the fore as, say, Hadoop becomes more of an enterprise-grade data platform for a lot of operational applications. There's going to need to be an increasing focus by organizations on governance regarding the data that gets loaded into your production Hadoop clusters to do things like cognitive computing. It won't be managed for us, rather it'll be managed by ourselves, meaning if we're IT professionals, data professionals, or it'll be managed by specialists that we hire and keep on staff to do these critical functions. And then model governance is a related phenomenon, which is that you're driving your operational business cognitive computing applications ideally from not just the best data but also the best models. You might have any number, say, of customer churn models in line to your various customer-facing applications, but ideally there should be one standard customer churn model used across all your channels at any point in time. And if that becomes less predictive of whether customers will stay or go, then the next best fitting churn model should be promoted into its place as a production asset. So model governance, somebody needs to define the rules that define what specific statistical models are in line to, say, your recommendation engines across all your different applications at various points in time. So governance doesn't go away. It's a human process that will need to evolve in this new era of cognitive systems where more and more machine learning models will need to be submitted to a strict regimen of governance because they're in production. You're betting your business on them.
Great. Thank you. So we got 2 more questions. How does a mid-sized company can adopt this big data where there is not much expertise available?
Well, a small to mid-sized company, there's the cloud alternative, of course. Clearly we have cloud offerings like Watson Analytics, and others do as well. Our competitors have their own fine solutions. So cloud, big data, and the cognitive computing that comes inside of cloud applications or is embedded into it is a way, of course, to do it on a software as a service basis, pay-as-you-go, subscription, and so forth. That clearly is a strong and excellent option for small to mid-market companies who don't have any internal IT capability or who may not have their own staff of data scientists, but they can acquire, as it were, or use pre-built services that incorporate all of this capability. That's one way to go about it. Another way is if they have, say, an IT staff and they have a data center, a mid-market company, they can invest in big data platforms that embed the statistical libraries and also the solution accelerators that can bring them up to speed on big data, on cognitive, on predictive. And you could hire your own data scientist, or you can hire consultants to do it for you. There's any number of approaches to bring it into the wherewithal or the capabilities, budgetary and otherwise, of small to mid-market companies that don't necessarily require you to hire a full bench of top-notch data scientists and to have a big honking data center in your own organization. It can be outsourced to a great degree, and increasingly a lot of this will be outsourced to a lot of professional services firms, but also cloud service providers.
Great, thank you.
Sure.
As a VA developer, what courses of study should I take to become useful in this field?
I think one of the core areas that you need to focus on in your studies and in your professional development is machine learning. And it's not a brand new field. It's been around for quite a while, but it has become very important that you at least get your competency boosted on unsupervised learning, supervised learning, reinforcement learning, neural networks, and so forth. The core technologies and tools that is associated with building and tuning statistical models. That's very important. So all things machine learning. And also, it's important that you just get a strong grounding in the basics of production data science. When I say production data science, data preparation is like 3/4 of the job. Getting the data in shape, cleansed and transformed, and so forth, to put it in shape where you can do downstream exploration of the data. Your data scientists can, to find patterns in the data. So you need data preparation, data integration. Critically important. You need to boost your skills there. You need to get deep, like I said, on machine learning and the associated tools and visualization tools on the development side. And but also you need to get your get a strong grounding in all the principles of cloud computing, because fundamentally this will be your new platform, the cloud, for executing ever larger and more complicated cognitive models against ever larger volumes of big data. So cloud plus machine learning plus the new era of unstructured data preparation. If you have a grounding in all those areas, then you're well positioned to grow your career. To take advantage, really to be put on the coolest, leading edge projects that more and more of your companies are putting out there.
Great. Thank you.
Sure.
So let's go ahead. Can you move to the next slide? Not
okay.
The next, not the following. Yes. Okay. Can you go to the following one?
Okay.
Great. So, like what you heard here, James will be presenting at the PAS Business Analytics Conference, and he will be the speaker for a breakout session, the full version of this webinar, Unlocking Big Data, the Power of Cognitive Computing. So, let's move to the next slide. Cool. So once again, the PAS Business Analytics Conference is April 20 to 22nd in Santa Clara, California. Visit PASBAconference.com to check out the great lineup of speakers who, along with Jen, will be presenting at the event. So let's go to the next slide. Cool. So stay tuned for our next session. Our next session is What's Next for Business Analytics in the 21st Century with Hyun Park, Jan Stirrup, and Miguel Martinez. So thank you, James, for delivering this session, and thank you, all of you, for attending. This was Paco Gonzalez. Thank you very much.
My pleasure.